I'm not going to read all this. You're here just for the answer anyway. Just make sure you've tried the practice set before checking your answer. So here's the equation we used in class is the energy of an electron in Bohr's model is equal to negative 2.18 times 10 to the negative 18 joules, and that's all multiplied by the nuclear charge squared over the energy level of that electron squared. The only difference here is that you don't see this negative sign in that K constant. All right, so this is the K and that's the constant. And the reason here is in this problem it's asking about the ionization energy. It's asking perspective is different. So how much energy is required to remove the electron? That's why it's positive. Whereas in class we're describing the energy of that electron. So that it's negative because the reference state is 0, and the lower the energy, the more stable the atom is, okay, or that electron system. All right, let's answer this question. It's got 3 parts to it. Let's do here, part 1 is what is the energy required to eject, remove that electron, or ionize? We can say a hydrogen atom. That electron is in the ground state. That's the lowest energy state. It's n equal 1. Energy to remove this electron is now going to be, we use this positive constant, 2.18 times 10 to the negative 18 joules. The nuclear charge for hydrogen is 1, so 1 squared is just 1, and the over the n squared, and n is also 1 because it's in the first energy, it's in the ground state. These we just ignore because they're just 1s, and the answer is going to be simply the constant, 2.18 times 10 to the negative 18 joules is how much energy is required to remove hydrogen's 1 electron from its ground state. Part 2, same atom, we've got a hydrogen atom. Now that electron is in the second energy level. It's in an excited state. So it's already got more energy than the first scenario. It's not going to take as much energy to remove that. Right, so the constant, 2.18 times 10 to the negative 18 joules. And hydrogen is still going to have a nuclear charge of 1. 1 squared, we can ignore that. But now the energy level is in 2. N is equal to 2. 2 squared is 4. Right, we can ignore that. And so our answer is going to be that constant divided by 4. 2.18 times 10 to the negative 18 divided by 4. 5.45 times 10 to the negative 19 joules. And as expected, it's going to take less energy to remove hydrogen's electron if it's in the second energy level, right? So here's another way to look at it. There's the nucleus, there's the 1 proton that hydrogen has. That electron is in the n equals 2. It's farther away, so they're less attracted to each other. All right, whereas here, nucleus, n equal 1, and they're more strongly attracted to each other because they're closer to each other. All right, so more energy here. All right, final scenario. How much energy is required to eject a ground state electron from lithium 2 plus ion? Now, the reason why they're doing this is because Bohr's model only works for systems or atoms with 1 electron. So it can be Li 2 plus, helium 1 plus, it can be any atom, but its limitation is Bohr's model only works with atoms with 1 electron. The constant 2.18 times 10 to the negative 18 joules. All right, now the nuclear charge for lithium is 3. Lithium always has 3 protons, otherwise it's not lithium. Right, so that's going to be 3 squared is 9. And because it only has 1 electron, okay, Li 2 plus has lost 2 electrons to become 2 positive. Electrons are negative. Right, so it loses 2, it becomes 2 plus. In any case, it has to only have 1 electron for this equation to work. So if it only has 1 electron, well, the reason I'm saying all that is the reason why it's important it has 1 electron, because if it's in this ground state, then it's going to be n equals 1. Otherwise, if it had 3 electrons like it normally does, then n might not equal 1 in its ground state. There'll be electrons in n equals 2 in its ground state. Anyway, I'm kind of getting off topic here. So n is equal to 1 because there's only 1 electron and it's in the ground state, which is n equals 1. All that I said, and we're just going to ignore that because 1 squared is 1. All right, 2.18 times 10 to the negative 18 times 9. 1.96 times 10 to the negative 17 joules. Right, and this much more energy to remove, because think about this, it's got 3 protons, all attracting 1 electron that's really close to it. Right, so this is like big attraction compared to these other first 2 scenarios. So this one's got the biggest, require the most energy to remove, followed by this thing here, and then that's going to take the least amount of energy.